Okay, our first speaker today, after the keynote, is Ben Deckroy. He's had over 15 years' experience in software engineering, usually using PHP, including aspects of security and practical application required a tool rather than just a scripting language. He's co-founder of BuzzConf, and he's excited about the future of technology and the community that defines it. He has been, or is, or was, an active member of the Open Source Developers Conference, LinuxConf.au, Melbourne PHP Users Group, Barcode Melbourne, and the Linux Users Victoria. We welcome him to Hobart and hand over to Ben.
Thanks. Melissa, I love you. Two of the most virulent viruses ever released back in 1999 and 2000 respectively. Melissa was estimated to have infected 20% of all computers worldwide. The ILOVEYOU virus caused millions of dollars worth of damage. And My Doom, which was another one of the big ones back then, $38 million worth of estimated damage just in those viruses. I don't know if you've ever seen the Melissa source code. It's bloody simple. It's really easy. And it's very destructive. For this reason, I would like to invite you all to please stand up. And hopefully my buzzer will start working. There we go. Please stand. Got it. So I'm one of those. Please repeat after me. I, your name, pledge to use the following information for good. If I fail to uphold this pledge, I realize you're going into this without prior knowledge, but stay with me. I will write a brainfuck interpreter and go. And I will give a lightning talk on the project at the next conference that I attend. If you were to take a seat, I will take that as implicit acceptance of this pledge. I generally try and encourage people to be a bit more participatory. And as a thank you to Jacinta for being the longest standing member, that came out wrong, didn't it? But for refusing to sit down as part of that pledge, I'm going to spill chocolate all over the floor. Ready? I'm going to delegate to you to give Jacinta chocolate. No, not at all. So back to the beginning. So going viral for fun, not profit. I want to talk to you about writing a virus, and it's about the fun and the excitement of creating new things and the playfulness of hacking, as opposed to the profitability of the viruses that destroy systems and lives sometimes. So first of all I'll do is go through and just talk about the various different ways in which a virus exists, what viruses are. They're malicious. They try and do nasty things, and unlike some fairy tale characters, they don't get better at the end. They generally get a lot worse. They like causing pain and harm. They replicate a lot. Dolly the sheep apparently died before her time. Viruses don't. They just keep going. One of the best parts of a virus is they're stealthy. They take advantage of weakest links. They'll go into a system, and so a lot of people say, well, why should I protect my computer? This could be security, it could be viruses, could be all sorts of things. Like, nobody wants my information. Scripts don't care. They'll just attack everything. They'll just go and look for weakest links that they already know about. They'll then adapt to avoid detection. And once they're in there, they will start stealing resources. Perhaps not fish, probably more likely to be CPU cycles or memory or disk. They'll then analyze the host environment and try and work out exactly what they can do. Are there any network devices they can connect to? Are they within a corporate network that has perhaps privileges beyond an external user? Are they within the DMZ, or are they within the private network internally? They'll then spread and infect. They generally don't do what mold does, which is quite random and move around. They'll replicate themselves accurately so that they're always the same. They don't mutate much through the replication. They can mutate themselves in order to avoid detection. And then in order to avoid detection, they will act ordinary. So back in 2001, with the 9/11 trade tower collapse in the US, the US Patriot Act came in And they decided what they were going to do is put all of these X-ray backscatter machines in, and they were going to up the security, the TSA lock down everything. Nowadays, you can't even walk through with your shoes on. The guys in Israel turned around and they said, that's a whole lot of bullshit. You don't need to do that. You just watch people. You monitor them. You use social psychological cues to work out who's doing what. And they still have standard metal detectors. They don't do the X-ray backscatter or any of that. They watch for what they see as cues for what would be not necessarily terrorist activity, but any kind of malicious activity within the airport. And viruses similarly have to escape that detection. And one thing that virus scanners do is they look for actions that make it look like there's a virus at play. So a lot of viruses will actually try specifically to not act like a virus, which is very hard when you're trying to be a virus. Adaption, evolution, again, if you keep changing, it's harder to see what's going on, it's harder to detect something if it's always different. Obfuscation, perhaps you don't necessarily look exactly like what you're supposed to be, or you're kind of hard to see in the first place. Something somewhat of a Trojan horse, perhaps. Perhaps rather than being totally obscure, you'll actually scramble yourself, encrypt the virus so that you can't even tell what's going on inside. And then the Trojan horse example again, acting benign, once you're in there, do nothing and be ready to pounce. If you're not quite ready to pounce yet, you might just lay dormant for a while until you're called upon to take action. But once you do things, take it slow. Again, if you start attacking a system really quickly, these watch monitors are going to go, hang on a minute, you're modifying 20,000 files in one go. That's not usual activity for a memory-resident application, so I'm just going to terminate you right now and notify the computer user that something might be going wrong. So, with that said, let's write a virus. So I have over here. So I am very bad at talking and describing at the same time as I'm typing. I'm sure most people are the same. It's the whole multitasking brain thing. So what I'm going to do instead is I'm going to use an awesome tool called Play It Again, Sam, which is written by a Melbourneian and allows me to basically mash my keyboard, look like I'm a totally proficient typer, while the words come out exactly as I intend them to. I should not have told you that. So let's go into the demo, and we're going to have a look at step. Files. Step 1. So first thing I'm going to do is I'm going to edit a file called boom.php because we want it to go boom. So this is generally what I'm going to do. I'm going to get a list of all the PHP files on the server. I'm going to check each file. I'm going to open it. I'm going to write to the file. And then I'm going to close it. But I don't know how much you know about editing files that might be open at the same time or files that are used by another system. PHP would have a process lock on certain files, especially if they are infected and running. So you can't necessarily always overwrite a file. So what we're going to do instead is to create a new file and then swap them over and then delete the original. Yeah. So file names is, let's grab all the PHP files. And then I'm going to go through each of the file names, and I'm going to open the file in read mode. Then I'm going to create an infected file in write mode so that I can start writing information to it. And the first thing I'm going to do is I'm going to create an infection. And for now, it's just going to be a comment that says file infected. Just a proof of concept for now. So let's write that to the infected file. I'm also going to pass in the string length because it's good practice, and I like to do good practice even when I am writing viruses, which I obviously do all the time. And then what I'm going to do is read every file, every line from the original file, and I'm going to write it into the infected file. So now at this point, the original file is still unmodified. We haven't caused any issues with systems that might be monitoring file changes on the system in order to note whether a virus is in effect. We're going to close the script. We're going to close the infected file, which is now written to disk. And then we're going to rename the original file to .original. Going to rename the infected file to the file name, so it's now effectively replaced it. And then just to clean up, I'm going to delete the original. And close. So now, if I just quit that, and we look in here, we've got boom.php, which is exactly what I just typed. Now, we've also got example.php, which is basically a for I equals 1 to 10. So if I run example.php, you'll see it echoes 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's the end of my talk. Thank you. No, so then what I'm going to do is if we run the boom.php, it doesn't do anything, or so it seems, because there was no output from the virus script. And in fact, if I now run the example script again, it still echoes out the numbers 1 through 9. However, if we look at the example file, which before was just echo the numbers, we now have file infected. So if I now create a new PHP file, and I run the example PHP file, and now we look at the new PHP file, well, of course it's not going to infect anything because I hadn't written the infection. I'm getting one step ahead of myself. So let's go into step 2. Please stop me at any time for questions. There are chocolates.
There were chocolates.
Oh, dear. So if anybody wants chocolates, please talk to Kathy. So let's look at the next step. So let's edit the boom file again. This is the file that we had previously. I'm going to make some modifications to the file. So the first thing I'm going to do is I'm going to come down here. I'm going to change the infection to add a virus in. We don't have a virus yet. So this is where the autotyper fails, but I'll show you a funky little script trick soon. So that A there is just ignore it. So I'm going to come in here, and I'm going to create a function execute, and it takes a parameter virus. And then I'll come down to the bottom. Apparently. And close that function off. I'm going to create a new file, which is a new variable virus, and the virus is going to contain the contents of the file. Very meta. Can everybody see what's going on there? So _file in PHP refers to the current file that's being edited. I'm basically getting the contents of that, and I'm putting it into the variable virus, which is then passed into the execute function. So the execute function will then load all the PHP files and write the current file that's currently in memory into every other PHP file that it finds, therefore spreading the virus. The other thing I'm going to do is I'm going to put a marker up here saying virus start, and I'm going to put a marker down at the bottom called virus end. And the reason I'm going to do that is because in here I want to strip out all the bits of the virus that are not the virus, which in this case is the start PHP tag, because otherwise you're going to get a PHP open tag inside a PHP open tag, and that's going to break. We don't want the system to break, otherwise you get an error. So you can see there that what I've done is I've said find the virus start, and then I found /n virus end. The reason I did /n virus end down at the bottom there is because otherwise it's going to find the virus end in that string. Whereas in actual fact we want to find the virus end down at the bottom. So we're looking for the top marker, the end marker, taking everything in between, and that then gets plastered into any PHP file that this script can find. Yep. So if we look at that file there, if we look at example, that again is just still echo the numbers 1 through 9. If I run example, it echoes the numbers 1 through 9. If I run the virus, we can now see that the example script has now been infected with the virus. So now if I do my next step, and rename that after I finish, so now I've got boom, example, and foo. If I run foo, it just does echo hi. If I do example now, which as we know has been infected because I ran boom, and we look at foo, foo has now also been infected. So I could keep doing this and create foo 2 and foo 3, but I'm sure you get the gist. Now, the downside to this is if we look at the boom, we've got up here virus start, virus function execute. And then we've got virus start, function execute. Then we've got virus start, function execute. Because I ran boom, which infected boom in example. Then I ran example, which infected boom, example, and foo. So boom infected itself and then got infected again by example. So now if I run boom, fatal error cannot redeclare execute. So we want to eliminate this issue. So let's edit the boom file again, and we'll go in here and in the infection, we're going to start the infection off with, I'll move over there, we're going to do an encrypted virus. Yes, we'll encrypt the virus first. So, and we'll get rid of the duplication afterwards. So now we're going to encrypt the virus. Has anybody here used the PHP encrypt functions before? Has anybody here done encryption in general in any kind of programming language? Is anybody not familiar with the way that encryption works? So there's two different block mode types. So essentially the way encryption works is that, there's many ways that it works, but the way that the PHP crypt functionality works is it'll break your data down into chunks, and you provide it with an initialization vector, which is a cryptographically secure randomized number, which gets passed in as a key, and then it'll encrypt that block with that, and then it uses the encrypted output of that block to generate the next key, which then encrypts that version. So essentially you've got this chain of keys that bounces all the way down the line as the file gets encrypted. So we're going to need to create an initialization vector for the encryption, and then we'll encrypt with that as well as having a key. So first thing we're going to do is generate the key, and I'm going to do a very secure key generation here. Let's create a 64-character string. And I'm going to pack that and then use that to, so the initialization vector here will have a size, and we're getting the size that's available for the REA128 encryption mode using CBC block cycle encryption, which is where the initialization vector goes into the top, but I won't go too much into how encryption works. So then what I'm going to do is create the initialization vector based on the IV size, and then I'm going to encrypt the virus using Encrypt. I'm going to use REA128, pass in the key and the virus. We're using mode CBC and the initialization vector. So this basically passes in all the information that PHP requires to pass off to the Encrypt module to encrypt the data. So now the only thing is that once the data is encrypted, we need our script to be able to decrypt it again, because otherwise it's not going to be able to execute. And what we're doing in encryption is just making it hard for a system to be able to detect that there's a virus. Because if you found a virus that had unlink in it, then you know that it deletes files, and therefore it might raise a score in the flag of virusy. I'm not sure if that's the equivalent to spammy, but you know, the virusy thing. So what we're going to do is we're going to encode the virus in base 64, so because it'll output a binary long string, and I want to put it into a PHP script. So I'm going to encode the virus, then I'm going to encode the initialization vector, and I'm going to encode the key. So now we have base 64 encoded versions of these 3 bits of information, which are all you need in order to decrypt it again. So now I'm going to create a string, which is PHP. So into that string, I'm going to define a variable called encrypted virus, which is the encoded virus. Naming conventions, they matter. The initialization vector goes in there as well, and the key goes in there. So now we have a string that, once evaluated by a PHP compiler, interpreter, will create those 3 variables in memory. Yep? I'm looking for glazed over eyes, because I am going through this quickly in order to fit it all in. So then what I'll do is again, this is still within the string, so then I'm creating something that, once evaluated, will decrypt using I've forgotten the name of the encryption now. With the decoded key and the encrypted virus and the IV. And then I'm going to evaluate that string. Execute it, passing in the virus. And now we have essentially what we had before, which was call execute, pass the virus in, and that will then run through and infect any other files that it finds. The only difference with this now is that what we're passing in to execute the first time is this payload. And the payload is the encrypted version. Does that make sense? So the first time I could encrypt this before I even send it off to a server, but the first time I upload this to a server, it's in clear text, and the first execution will be to encrypt itself and then stick it into a file. Cool. So let's come down here and save that. So now if we look at boom.php, we've got the payload, the encrypted information that's going to go in. And if we have a look at example.php, we can see that it's still a bog standard PHP file that's not been infected. If I now run boom, let's open this up in Vim because it'll be slightly easier to see, debatably. There's the encrypted version of the virus. And if we compare this with, let's do a vertical split on boom. So the Yeah, Boom's infected itself, so I'll just skip down under that. So this is the original unencrypted plain text virus, all the way down in Boom. And on the right-hand side here, we've got the encrypted virus and the initialization vector, which are pasted at the top of the file. But there's no real evidence here that you're infected with a virus. You just know that there's some stuff going on at the top of this script. Except the variable name. Yes. So some options around this are to define your variables in a different language, perhaps. Klingon, maybe. Unicode. You can just have every character exactly the same looking, but they're actually different characters. That would be a great way of obfuscating your code in Unicode. Not that I'd advocate that if you're actually doing software development and want it to be maintainable. Although you could argue that it creates job security. So we now have the infected virus in the encrypted virus in the example.com. So let's just try the foo.php example again. So foo. Hi. And now if we look at foo.php, we see that that has also been infected. And in fact, if we look at example.php, it has been infected twice, but can anybody notice something interesting about the way that it's been infected the second time? Different key, different encrypted virus string. And in fact, if we open them both up again, so the top one here that you can see is the most recent infection. The bottom one was the original infection. And now compare the most recent infections of the two files that happened during the same execution just now of execute. Even those are different. So when I was running the code, I was doing the insert the encrypted virus. I was calling that function every time I opened a new file, rather than just once at the beginning of the script. You could argue that's not very good for performance. However, I don't care about performance because I'm writing a virus. What I want to do is create as many different versions of this virus so that it's even harder to detect. So now if I was to infect 200 files, every single one of them will be slightly different. And if I then also randomize the variable names, those will be slightly different. And if I generated a string that contained the letters E, V, A, L in certain positions and then picked those out to generate a string called eval, which I would then evaluate as a variable, then you wouldn't even have the word eval in here, and then it's even harder to detect. What about the fact that the files have just grown by the same amount? In this particular case, they would. You could get around that again by putting in dummy data, a whole lot of variables that you also want to insert data in, or even just by putting in dummy variable stuff in here, so the amount of data would change. But again, that's something you need to look at in terms of what's normal activity. So a virus scanner might look for 7 files that all increased by 275 bytes. On the other hand, they might trigger if 200 files changed, even though they were by slightly differing file sizes. So there are definitely a lot of things that you need to take into account. And PHP files editing other PHP files is generally not on. Correct. But it's a thing. It gets done, unfortunately. And we'll actually have a demo of that in a bit. So let's go to the final step, which is the point at which I try and make sure that it's not infected multiple times, thereby breaking the original script. So let's edit the Boom file, and I'm going to come down here, and I'm going to find all the editable files that I want to do. Now, the reason I'm doing this is because in order to demonstrate the script, I'm going to run it in a Vagrant box. As you can tell there, I'm finding everything in vagrant/www. The reason for that is that when I run the demo, I don't want to kill my laptop. So if you decide you want to play with viruses that delete everything in your system, or modify every PHP file on your system, or whatever language you use, do it in an environment where you don't really care if everything's lost. I learned that the hard way. So I'm going to, I'm basically looking for all PHP files in the vagrant directory, and then I'm going to check if the file is not infected first. So the first line is going to be pulled out. So before what we were doing was pulling out a line and writing it straight in. What we want to do first is get the first line and check it, because we're going to see whether or not there's a marker in there saying I'm already infected. So we're going to create a hash of the virus by taking a seed seed. I don't recommend you use the seed for any of your hyper-secure applications. Again, for the purposes of writing a virus, you're probably fine. And the only reason why I'm doing this in taking the file name as part of the hashing mechanism is, again, for that uniqueness. I don't want the same hash in every file. So we'll create a unique hash based on the file name that we're infecting. And we will see if that virus hash exists in the first line of the file that we've just opened. If it does not, just going to tab those all in slightly. So if it does not, this is where the script really breaks. But hopefully you can kind of see what's going on here. So we're going to create a checksum of a line in the file. This is the checksum, and here's the virus hash. And we're going to write that into the infected file first. And then what we're going to do is write the first line that we pulled out, because, of course, when we go into the while loop next, the first line will already have been pulled. So we've pulled the first line out. We've checked it to see if the checksum matches. If it does not, then we write the checksum into the infected file. Then we write the first line in, and then we go back into the while loop down here in order to pull the rest of the file out to infect it. And then I'm just going to write a create epitl files, which is basically going to iterate through a whole lot of directories from a starting point. And in order to not draw attention, we're going to make sure we only pull out 10 files at a time. Again, we don't want to do 200 files. And perhaps we can put some randomization in to change the amount that the file is increased by in terms of file size. And clean the path to make sure that there's no gumph in there, because despite the fact that it's a virus, again, I like to follow certain kind of standards, so I have a reputation to uphold. If it's a directory, loop through it. You know what? I'm just going to kill this at this point. Because I've got a faster way. I'm just going to copy .boom to boom. Always have a backup plan. So if we look at the boom file now, as well as there being extra files, let's get rid of the swap file and the play it again Sam session file. Vim boom. So we now have the virus up here. We get the editable files. We check to see if it's not infected. If the first line is not the hash, then we infect it, and so on and so forth. So now we've got, again, the boom and the example. Example still as standard before. If I run boom, let's just use head. So you can see here that boom has not reinfected itself. And if we look at the example, you can see. Did I run boom? It's not infecting for some reason. Live demos always go wrong. Thank you. It's looking for files in my vagrant directory, which does not, in my vagrant dub directory, which does not exist on this machine. So instead, if I jump over here and I jump into my SSH box, my vagrant box, I have over here index.php, show image, and upload. I'm going to very quickly go through these. I've written a gallery system, and essentially the gallery system will, at this point here, basically find all the files outside of the doc root in the gallery images directory in order to display them. There's an upload mechanism, which will basically find the acceptable MIME types are defined. It'll find whether or not the file that you're uploading is one of those MIME types. It'll then sanitize the file name to make sure you don't have any injection attacks. It'll move the file to the images directory outside of the document root, all best practices still, and then it'll redirect you to the home page. And when you view the image, it uses the show image PHP. So rather than saying image source equals here's the JPEG, because it's out of the doc root, it's not available. So it uses a PHP file to include it, which will also make sure that, first of all, the referrer is correct, It'll then make sure the file name is sane. It'll then check the file type based on the EXIF of the image, rather than using the information that was uploaded with the file variable with the upload, because that isn't actually trustworthy. It's user-generated content. It'll then set the content type to ensure that what's about to be displayed to the browser is actually an image, and then it'll show the image. So I've tried as much as possible to make sure that the gallery has been written with best practices in security in mind. Let's now jump back over here. So in my images directory in the demo files, I've got a file, and a little bit of trivia here. You can't autocomplete JPEG files when you use Vim at the command line. I'm not sure why they never thought you'd want to edit images in Vim, but there you go. So I have here a JPEG file, as you can all quite clearly see. It's very pretty. So what I'm going to do is at the end of this line here, which is basically the metadata saying, hi, I'm a JPEG and this is my quality, I'm going to enter a line in under here. And then from step 5, I'm going to grab boom.php. I'm going to yank all of those lines out. I'm going to paste them in there. I'm going to go down to the bottom. I'm going to close the PHP tag. Yes, I've just put PHP into a JPEG file. Now, I'm going to jump over to the gallery. I'm going to browse for that file, which is right here. And you can see the preview is still bread.jpg. It still looks like bread. I'm going to select that. I'm going to upload it. And you can see that it still says bread. It still looks like bread. And yet, I've just infected the system. And I can show you that by looking at the index file again, and there's the checksum. So now, interesting things I can do. It would help if my N key actually worked. PHP. Demo fail. Right, so let's just have a quick look at the, how am I doing for time? 5 minutes, excellent. I can get through this. Step 5, boom. So, BIM. New file, interesting. Ah, Vim. Right, so down here, I basically added some code in saying, get the exec variable. That's why it's not working, because it's exec. There we go. So we're echoing out PHP info and not executing it at the moment. That's because it should be eval. So I made an update to my talk last night. Great move. Let me just see if I can fix this quickly. And then I will delete the where are the files? Gallery images, there it is. Delete bread and go back to the home page and reset the files. So now index is uninfected again, and we have an empty gallery. So let's try uploading that file again, which I need to reinfect. Right, let's see how this goes. So let's choose bread.jpg, upload it. So now we've got an image, and you'll notice that immediately after that it's broken because it's infected the system. And now if I do eval equals php info, we should get a php info, which we don't. So I'm more than happy to demonstrate. Oh, I'm no, still not working. Oh my God, that's a thing. PHP requires semicolons. So now that I have that working, that's really good I did, because I wanted to show you something. Now that you can basically evaluate anything, you've got a whole lot of drone machines set up all around the world that can do your bidding. So let's try some interesting things like print glob star. There's a list of all the files in the directory. Now, let's try a longer one, quite a lot longer one. And let me just bring this over here so you can read it. Can you read that at the back? So basically what I'm going to do is I'm going to evaluate file put contents into a.php I'm going to write, open PHP script tag, header equals location http://osdc.com.au. File put contents, so there's now a file put contents in the file put contents because I'm putting contents into a.php, which is the string of file put contents, into index.php. So a.php is now going to write into index.php, header, go to this location. Clear as mud?
Yes.
So it does. Let's see if that worked. I'm not sure why it echoed that out still, but hopefully it. Oh, it didn't. That's a shame. The most fun one. The most fun one is, I'm not sure how easily readable that is, but basically file put contents into a.php, find all files, and delete them. And of course, because the virus that I wrote had the method in it, the function in it that would find all files, you could even call that, because that's available from within the virus, and say, use this to find from the root any file whose file name is star, and delete it. And then you've just wiped somebody's entire system. So, with the very little amount of time I have left, and the fact that this always starts from the beginning, which takes up even more of my time, I'd like to thank you all for... I hit Shift F5, but I think as with the N key, the Shift key's not working either. So why did I do this, or what was the point? The main reason is to hack and to play. I was asked, what's the most interesting way of teaching people how to do security? And most people do security talks. I try and teach people how to be bad. Because at least this way, now you can think about how virus writers think. And if they're having, if they're writing systems that are going to break your applications, and you know how to do that as well, then perhaps you can bear that in mind when you're writing them and apply a bit more security thinking from the other perspective. The other thing is that it's really good fun to just play with something that's not going to be for production. It's not useful in a saleable sense, but it's just a way of getting your fingers dirty, your hands dirty, and playing, again, with the tools that we use every day, rather than it being a day job again. So please remember your pledge. I was serious. I will expect at least one person to fail, and I want to see their talk. And thank you very much. I suspect I don't have time for questions, but please find me during the break.
Good. Thanks, Ben. And so you can remember you've been to Hobart. We've got a little gift for you.
Thank you.
And you've already thanked Ben. And yeah, we've got practically no time for questions, I suspect.
No, I don't think so.
Not really.
Switch straight over.
We've got about 4 minutes for the next speaker to get ready and come up. Good. Thanks, Ben.